In the last chapter, we solved some equations involving whole numbers, and now we're going to solve some equations involving integers. And actually, the solving of equations with integers is about the same as solving equations with whole numbers. We just have to remember that whatever operation we perform on one side of the equation, we perform the same operation on the other side, and we're fairly safe. For example, if we have x plus 5 equals 12, we see the addition of 5. And we've seen this kind of problem before. To eliminate the 5 and cause the equation to tell us the solution, tell us the value of x that causes this statement to be true, then all we need to do is undo this addition of 5. And to do that, we'll subtract 5 on both sides. So we write this side and subtract 5. We write this side and subtract 5. And now the 5's go out here, leaving x, and on the right, 12 minus 5 is 7. And this is the solution to the equation. And we know it's a solution because if we replace x with 7, we have 7 plus 5, which is 12. 12 equals 12, a true statement. Now for this one, now notice we have this time x minus 5. We're subtracting 5 here. Now to undo the subtraction of 5, we would add 5. We do the inverse operation. So we bring down x minus 5 and we show the addition of 5 on the left. And if we add 5 on the left though, we have to add 5 on the right. So we show this. The 5's again go out. Negative 5 with positive 5. They're out of here. That's 0. So we're left with x. And on the right, 12 and 5. 17. And once again, we can check rather easily if x is replaced with 17, 17 minus 5 would indeed be 12. 12 equals 12, a true statement, a valid solution. Here's another one. Here the unknown quantity is on the right side of the equation. That's no big deal. We just want to isolate the letter on whatever side of the equation it appears. It appears on the right, so we want to isolate on the right. We do that by eliminating the plus 13. To eliminate 13, we subtract 13 on both sides. So in the next step, we write the left side and we indicate that we're going to subtract 13. We write down the right side and indicate we're going to subtract 13. On the left side, negative 15 with negative 13 is negative 28. And on the right side, 13 minus 13 would be 0. So we have simply t left on the right side. Negative 28 is the solution. Once again, we could check the validity of this solution by replacing t with negative 28. Negative 28 plus 13 is negative 15, and negative 15 equals negative 15, a true statement. Here we have a situation where a number is multiplied times the letter, and recall that to undo that situation, we divide by that number next to the letter. So here we're going to indicate that we'll divide by 5, and if we divide on the left by 5, we need to divide on the right by 5. And that's all there is to it. Here's what we want to write though, and be sure to write this step. Don't just assume that you know how this is going to take place. And this is a relatively simple equation, and I'm sure that in a lot of cases like this, you'll be able to see through the correct answer. But that won't always be the case. And we want to lay the groundwork here for a correct procedure that can be applied to much more complicated problems. So that procedure is to decide what we're going to do. We're going to divide by 5. And now show what we're doing on both sides of the equation. And it looks like this. And now perform the indicated operation. When we divide by 5 here, these cancel and we have n on the left. On the right, we have negative 20 divided by 5. Signs are different. We get a negative result. 20 divided by 5 is 4. N is negative 4. And once again, we can check this. If we replace n with negative 4, we have 5 times negative 4. Negative 20 equals negative 20, a true statement. Here again, we have a number next to the letter. That number is negative 8. We're going to divide on both sides by negative 8. We indicate it like this. Bring down each side and show that we're dividing by negative 8. You know, it might be worthwhile for me to elaborate just a little bit about why the negative 8's sort of disappear here. We kind of think about them canceling, and we think negative 8 divided by negative 8 is 1. And really what is happening here is this, that we think about this as negative 8 over negative 8 times a, kind of like this. and an integer divided by itself becomes 1. So this is 1 times a. 1 times a is a. And that's why we kind of jump to the conclusion here that on the right side of the equation, we're left with the letter a. All right, so over here we're left with a, and on the left, negative divided by negative is positive. 32 divided by 8 is 4. So 4 is the solution to the equation. And again, we could check it if we'd like. Here, the negative 7 is going to be divided on both sides to clear this number next to the letter. So we have this side divide by negative 7, the right side divide by negative 7. These go out by that same little routine that we talked about earlier, leaving x, and on the right, positive divided by negative is negative. 21 divided by 7 is 3. Negative 3 is the solution to this equation. Here are a couple of word problems. This one says a jeweler wants to make a profit of $250 on the sale of a gold bracelet that cost the jeweler $700. Use the formula P equals S minus C to find the selling price of the bracelet. Now, P stands for profit, S is the selling price, and C is the cost. Now, does it make some sense that what's happening in this situation can be explained in a lot of different ways? When a merchant like a jeweler buys a product like a bracelet for $700, in order to sell that product and make a profit, they add some money to it. And the money that they're adding to their cost becomes their profit. So another way to look at this, we could look at this formula in a couple of different ways, but it is that the cost plus the profit is equal to the selling price. And the way we're using the formula, though, is that the profit is equal to the selling price, take away the cost, you see. So, all right, and so let's use it in the form in which it's given to us right here. But it's P is equal to S minus C. Now, when a problem like this is written in the textbook, it'll tell us what P stands for and what S stands for and what C stands for. And when you're given a formula in the textbook, don't be intimidated by that. It's really not a big deal. Just write the formula down and look in the problem for the items that are described in the formula. So we're looking for the profit. It says let's see, use the formula to find we're finding the selling price. We're looking for that rascal. We're given profit and cost. So let's see, the profit here is $250. And the cost is given as cost the jeweler $700. So we have this. All right, and now we're trying to solve for S, the selling price. And to isolate the S on the right side of the equation, we want to eliminate this minus 700. And we can do that by adding 700 on both sides. So we have 250 plus 700 on the left. And on the right, we add 700. And these two together give 0. So we've isolated S, selling price, on the right. And on the left, we perform the operation to find the selling price to be $950. So $950 is the selling price of the bracelet. This one says, find the airspeed of a plane whose ground speed is 624 miles per hour and for which the headwind speed is 98 miles per hour. Use the formula G is equal to A minus H, and it would be explained that G is ground speed, A is airspeed, H is headwind speed. Now we can kind of blindly just replace within this formula and arrive at an answer. It might be worthwhile that we talk about the notion of ground speed and airspeed here. The ground speed is the speed of the airplane in relation to the ground. How fast, compared to the ground, is the airplane flying. Airspeed is a speed that you might think, well, the wind is whistling by. How fast is the wind whistling by? That's kind of like the idea of airspeed. It's whistling by at 50 miles an hour, so we have a 50 mile an hour airspeed. Now, why are those different? Well, it turns out that that if an airplane is flying in still air, let's say an airplane flies at 100 miles an hour in still air, and if the airplane has a tailwind, then the wind is helping the airplane fly. It's making the airplane go faster. So the airspeed would be 100 miles an hour. It's going through the air at 100 miles an hour. But in relation to the ground, since that tailwind is helping it along, it's really going faster than that in relation to the ground. How fast is the ground going by? You see, you can think of it like that. And on the other hand, if it's facing a headwind, then the airplane can't, the wind is coming at the airplane can't go quite as fast. You see, in terms of the ground, the airplane is working a little harder. So the airspeed, ground speed kind of thing changes with headwinds and tailwinds and so forth. Well, here is our formula relating those three ideas. And all we're doing in this problem is we're making a calculation just according to the formula. So we write G equals A minus H. G is ground speed. Do we have that information? Sure. Ground speed is 624 miles per hour. A, airspeed. It says to find the airspeed. All right, this is what we're looking for. Now, we're going to take this A and subtract the headwind speed, which is given to be 98 miles per hour. And away we go with solving. To isolate the A, we want to clear the minus 98. To do that, we add 98 on both sides. So we write 624 plus 98. We bring down the right side, add 98. These go out, leaving A on the right side. And on the left, 624 plus 98 is 722. And that's 722 miles per hour for the airspeed of this airplane.